Hi everybody, welcome to today's Saturday session with Exam Revision. So today we're going to look at two small Leaving Cert topics for ordinary level. So they're indices and scientific notation. Okay, they're quite short chapters, but it does come up quite regularly in the exams, so they are important. For indices, I'd usually link indices with algebra when I'm teaching it, and scientific notation can actually come up with any topic on your Leaving Cert exam. So we'll kind of look into more about what that is when we get into the video. So what we're going to do, we're going to just look at applying the rules of indices, where to find them. Then we'll look at solving with indices, so when x is the power. Then we'll do some work with surds as well. And then we'll go on to our scientific notation at the end and then look at a few exam questions. So first, where do we get our rules of indices? So the good news is you don't need to learn them. There is a few bits along the way that I will highlight that you do need to learn off by heart. But in general, your rules of surds or your rules of indices or your laws of surds, as they're sometimes called, they're on page 21 of your formula book. Now, for higher level, you do need the log rules that are on the right-hand side there. But for ordinary level, we don't. Okay, so for ordinary level, it is just the rules there that are on the left. Okay, there is 9 of them, and we're going to look at using them, looking at which ones come up the most often as well. Okay, so what we're going to do now, we're going to get straight into a few questions. So as you can see here on the right hand side, I have just cut the rules that are relevant to the ordinary level course. Okay, now the question on the left hand side there, it says simplify. So if something says simplify, it just means basically make it look nicer. Okay, so if we are simplifying, we see, okay, we have powers. If we have powers, we're going to use our laws of indices. Now, what is very important about our laws of indices is that they only work when our bases are the same. Okay, so we can see here, the top one, we have a to the power of 2, or a squared, multiplied by a to the power of 3. Now, all we're going to be doing, we're going to be matching these to a law. So one of these 9 down here. Now, I can see up here, when we have two things squished together, there's actually, you can write a multiplication sign in there if that will help you. Okay, so my question matches up exactly with that first law. So when it's a to the power of p multiplied by a to the power of q, I want you to look at what happens to the powers. Okay, so the powers get added together. So I can change this a squared multiplied by a cubed into a to the power of 2 plus 3, which is just a to the power of 5. Okay, now just something to note, and it will become more relevant later when we're working with more numbers. If it was a squared multiplied by b cubed, okay, we can't apply a law of indices there because our bases or our big number are not the same. Okay, so for these to work, you need the bases to be the same. Okay, question 2 then, or part 2 of it, we see they're dividing. So look over to the right hand side, look at our rules and try to match it up. So there, it's the second one. Okay, when we're dividing, what does the rule say to do? It says to subtract the powers. So that will be x to the power of 8 minus 2, which is just x to the power of 6. Again, we can only use that rule when the bases are the same, so there was x's in both parts. Next one then, y to the power of 4, all to be squared. Now, this matches up well with this. Okay, it matches up exactly with that. So when it was a to the power of p, all to the power of q, again here, when they have things squished together, that means they're being multiplied. So that's actually p multiplied by q. Okay, so when we have a power raised to a power is how we describe this situation here. We multiply the powers. So that's going to be y to the power of 4 by 2, which will be y to the power of 8. Okay, so those first 3 things there, they're just straightforward applying the rules of indices. The last part here now, we're going to get into the first thing that I said we need to learn off by heart. Okay, so I'm just going to write a little bit bigger down here. So we have the square root of b all to the power of 8. Now, when I look over here, I can see here I have something about a square root, but it has something funny sitting up there. Okay, so if I had, for example, I'm just going to make up a new question. If I had the 5th root of a. Okay, so I have something that looks like this. I can change that into a to the power of 1 over 5. Okay, that's nice and straightforward. That is applying a rule. I know it's kind of working backwards, so you're going from this side from there back to there, but it is still applying a rule. Okay, the problem is here, we have no number sitting on the tail here. Okay, so there's nothing sitting there. Okay, now this is something you need to learn off by heart, and it has come up in papers before. So I'm going to change that. And I'm going to put a little 2 there. Okay, so if there is no number sitting on the tail of the square root, what you need to do is you need to write the number 2 there. Okay, now I can use this rule here. So I can say that that is b. So I have something that looks like this. We're going to work it back. Okay, so I'm going to say that that's b to the power of a half all to the power of 8. Okay, and now what we actually have, we're now going to be able to use law 3. So we're going to go back up to that third one. When you have a power raised to a power, you multiply. So it'll be b power of a half multiplied by 8. And if you're unsure what that is, pop a half multiplied by 8 into your calculator and you'll get b to the power of 4. Okay, so basically that last question is where things are going in a second. It is going to get a little bit trickier and people find that quite challenging, but there is the first thing you need to learn off by heart. So if you want to make a little note, if it is a square root like that, okay, I'm just going to put an x in there. That's the same as putting a little 2 there, which is then the same as to the power of a half. Okay, so that there, just to know that a 2 goes on the bottom of the square root if there is no number there. Obviously, if there is a number there, like up here when I had the 5, there's no need to change it. You can just apply your rule directly. Okay, so there's a little practice of applying the rules. Obviously, there are a few more rules there that we haven't covered. We'll come to those now when we're doing the kind of solving questions in a second. Okay, so now moving on to the next type of question. Now, my writing here isn't great. That is a square root of 5, not 25. Okay, so we want to write 125 all over the square root of 5. And we want to make it look like a to the power of b. Okay, in other words, we want to make it look like something to the power of something. Now, if you just try for a second and just put that into your calculator. On your calculator, you're going to get out 25 square root of 5, which does not look like our answer. They do not want you using a calculator here. Okay, in a second, we'll kind of be using a calculator to cheat just to know what power to use. But in general for these, they do not want you using your calculator. If you just write down the answer and not show your work, what they're testing here is, do you know your rules of indices? Okay, so when we don't know our rules of indices, you might be able to figure out the answer in certain cases, we'll see later on, but you will not be able to get your full marks unless you show all your work. Okay, so for this, I have a fraction. Okay, so my first thought, where do I see a fraction over here? I see a fraction up here. Okay, I made a very important point earlier that everything needs to have the same base. Okay, so right now these are both completely different numbers of 125 and square root of 5. There is something we should have learned from the last slide. I can change that square root of 5 into, we'll just go down here. I can change that into, I can put the little 2 there, and then suddenly I am using this law here to make that 5 to the power of a half. Okay, so instead of writing square root of 5 underneath there, I can write it as 5 to the power of a half. Okay, that's kind of one problem solved. Square roots in general are a little bit awkward to work with, so if we can get rid of those, it is fantastic. Now, next thing, the 125. Okay, and I want to make that 5 to the power of something. Okay, so what I'm going to do, I'm going to try 5 squared on my calculator. 5 squared is 25, that doesn't work. Next one, 5 cubed is 125. Okay, so I know I was saying don't use your calculator, but you can kind of use your calculator there to cheat a little bit. Okay, so instead of writing 125, I can write that as 5 cubed. How did I know to do that? It's because we want all our bases to be the same. Okay, now I've 5 as both my bases, so I can actually apply this rule now of indices. Okay, when they're dividing, they're the same base, you can subtract the powers. So this is going to equal 5 to the power of 3 minus a half, which is going to equal 5 to the power of 2.5. Okay, that answer now looks like a to the power of something, or a number to the power of something. So that is our final answer there. Okay, now as a little check, what we're going to do, now you're not going to get any extra marks for this. Okay, into your calculator, I want you to put 125 all over the square root of 5 and press the equal to button. Now press the SD button and you're going to get out a really long decimal. I'm just going to make a quick note of it. 50169 ... Okay, now what I'm going to do, I'm going to put in 5 to the power of 2.5, so our answer, 5 to the power of 2.5, that also gives me out 55.90169 ... Okay, so all we did, we took this and we made it look different. We put it into this form, but we didn't change any numbers along the way. Okay, so that check there, you're not getting any extra marks for it, but just if you are unsure, it's kind of handy just to be able to check a little bit. Okay, now we're going to get into the solving type of questions next. Okay, so we will start here with question 3. Okay, so I'm just going to make a note of that down here. So it's 5 to the power of 3x minus 1 is equal to 5 to the power of 8. Now, in general, and there's no exceptions to this, anytime a question says solve, what they want is x equal to a number. Now, if the number may not be x, in this case, we are working with x's, but if there was y's in your question, when they say solve, they want y is equal to a number. Okay, now, question 3 here is actually relatively straightforward. Okay, when we have the bases the same, so here they're both 5s, okay, we can just cross them out. Okay, and we can let the powers equal to each other. Okay, so we can say that 3x minus 1 is equal to 8. Now, we'll only be able to do that. That will be the last step for most of the harder questions. Now, we can only do that when the bases are the same. Now, all I have to do is solve for x. So, if you are unsure of any of this kind of algebra about solving, it is better to fix that problem now because it will affect every topic you do for your maths. But we're going to go through this one. So, we want x on its own. First, I'm going to get rid of that minus 1 by plussing 1 to both sides. That will leave us with 3x is equal to 9. Now I'm going to get rid of that 3 from in front of the x by dividing both sides by 3. So that will leave us with x is equal to 3 as our answer. Remember the question said solve, so we want x equal to a number. We get x is equal to 3. Okay, again, what I'm going to do here, I'm not going to do this for all the questions now, but we are going to just check our work here. We'll check them for a few. Okay, unless the question says verify, which one of the exam questions that we'll see at the end actually did, you're not getting any extra marks for this, but it is kind of a peace of mind that you'll know that you have your answer correct. So the question was 5 to the power of 3x minus 1 is equal to 5 to the power of 8. Now, 5 to the power of 3 by 3, because we found x was 3, is equal to 5 to the power of 8. What I can actually just do here, I can say 3 by 3 is 9, minus 1 is 8, is equal to 5 to the power of 8. Perfect. So that is our correct answer there. Now, again, they will probably come up a little bit trickier. Every question we do here is going to add on an extra step. Okay, so that's kind of the most basic. We are going to be seeing that method again, but kind of we'll have a few steps to do before that. Okay, so question 4. So for 4, we have 3 to the power of 2x plus 1 is equal to 27. Now, the most important thing, and I've said it a couple of times already, but I'm going to keep saying it for the whole time, and probably the most important rule for indices is that your bases are the same. So we can see here that the base on the left-hand side is 3, and the base on the right-hand side is 27. So that doesn't work. So I'm going to go off to the side here, and I'm going to try and change 27 into 3 to the power of something. So I'm going to try 3 squared. That gives me 9, so that's not right. I'm going to try 3 to the power of 3, which gives me 27. So I can then write 3 to the power of 2x plus 1 is equal to 3 to the power of 3. Now from here, we're actually back to where we started with question 5. We have the base is the same, so we can say goodbye to those, and then we're just left with 2x plus 1 is equal to 3. And now just a little bit of solving, so we'll subtract 1 from both sides. 2x is equal to 2. Divide both sides by 2. We get x is equal to 1. Okay, I'm not going to check that one now, but if you have that extra bit of time in your exam, no harm just to check it. It will only take you 2 minutes. Okay, and finally then question 5 says 27 to the power of 2x is equal to 9 to the power of x plus 6. Now, for this, again, we have the 27, we have the 9, they're different bases, that doesn't work. So we need to change them both into the same base. Now, once you get familiar with these and you do a few practice, you'll realise what numbers tend to work, okay? I'm going to see if I can change 27 into 9 to the power of something. So try maybe 9 squared, that gives me 81, that's way too big. So 9 isn't going to work as a base. When I see the number 9, I can think, okay, immediately 9 is equal to 3 squared. Can I write 27 as 3 to the power of something? 27 is equal to, play around with your calculator, 27 is equal to 3 to the power of 3. Okay, so I can write 27 as 3 cubed. Remember that 2x outside it. And we can write 9 as 3 squared. And remember the x plus 6 outside it. Okay, now we have the same base, we're on the right track, but there's still brackets, it's still looking a little bit too complicated. The rule now that applies, so we're going to go to your rules of logs, or rules of indices even, and I can see what I have, both of this and this, they look like rule 3 up here. Okay, so we want to get rid of that bracket, so we multiply the powers. Okay, so this will be 3 to the power of 3 multiplied by 2x, that'll give me 6x, is equal to 3 to the power of, now 2 multiplied by x will give me 2x, and 2 multiplied by 6 will give me plus 12. Now I have the bases the same, the brackets are gone, so we can just let the powers equal to each other. So it'll be 6x is equal to 2x plus 12. We will get our x's to one side, so minus 2x from both sides. That'll give us 4x is equal to 12. Divided by 4, we get x is equal to 3. Okay, so what you need to do is you need to build this up. So we started with question 3, kind of an easy enough rule, brought it up then to question 4, where we were changing one base, and then up to question 5, we were changing both to the same base. Okay, so we're going to go on now again, and we're going to look at question 6. So each of these again are getting a little bit harder until they're each kind of as hard as they can get for question 8. Okay, question 6 though first. Now there's a few ways to do this. 1 over 32. Okay, now for me the most obvious thing first here is that we have different bases. So I'm going to just focus on the 8 and the 32. Okay, so there is no way of writing 32 as 8 to the power of something, okay? Play around at your calculator, all the numbers are going to come out way too big. Okay, 8 and 32, I'm going to try and see if I can make them both 2 to the power of something. So over here in rough work, 8 is equal to 2 cubed. And 32 is equal to, just checking the calculator, 2 to the power of 5. Okay, so I'm going to rewrite this question. So instead of writing 8, I'm going to write 2 cubed. Just let that x, 1 all over 2 to the power of 5. Okay, I'm going to get rid of this bracket here, so that'll be 2 to the power of 3x is equal to 1 over 2 to the power of 5. Now from here, there are two ways to go, but I'm going to look at my rules of indices and I'm going to see if there's anything that kind of matches up. And I can see what I have here looks very like this here. Okay, now we can work backwards and we can make that look like a to the power of minus p. So what will this actually equal to? I can say that 2 to the power of 3x is equal to 2 to the power of minus 5. Okay, so when you have 1 over something to the power of something, get rid of the 1, the power changes to a negative sign. Now here we've our base is the same, so we can just let the powers equal to each other. So we get 3x is equal to minus 5, x is equal to, we'll divide both sides by 3, minus 5 over 3. Okay, don't always expect very nice answers. If you got out maybe an awful decimal for this, then I would be a little bit concerned, okay? But that answer there is correct. You can check it. It'll only take you 2 seconds to check on your calculator. If you get out a fraction like that and you're a bit like, oh, that doesn't sound quite right, but if you do check it, you'll see that that is right. Okay, question 7 then. So same kind of idea. If you're confident with these, feel free to pause the video, give it a go yourself, and then check back to see if you have the right answers. Okay, so what I'm going to do first, again, I can see I have 4s and I have 2s. They need to be at the same base. I know I can easily change 4 into 2 squared. So that's going to be 2 to the power of 2. Okay, I'm going to kind of work as I'm going along here. I can see I'm multiplying. Multiplying is rule 1. So we add the powers. So that'll be 2 to the power of 4 plus 2 will be 6 divided by 2. Now, I like everything to have a power. So I can actually just put a 1 here. So if you have 2, it's the same as 2 to the power of 1. If you have 10, it's 10 to the power of 1. So this will be 2 to the power of 2p, law 3. And then here we can subtract the powers because we're dividing. So it'll be law 2. So this will be 2 to the power of 6 minus 1, which will be 2 to the power of 5. And again, now we have our base is the same. So we know what to do from here. We get out that 2p is equal to 5, so divide both sides by 2. If p is equal to 5 over 2, or you could write that as 2.5 as a decimal if you want. Okay, and then the last one, this one probably looks the trickiest, and is as complicated really as they can get on an exam. So we have 3 to the power of 3x minus 1 is equal to 27 all over the square root of 3 to the power of 5. Now, there are a few different ways to do it. I'm going to use kind of what we have been doing so far and keep to that kind of trend. First thing I don't like there is I don't like the square root of 3. Okay, so I can straight away change that into 3 to the power of a half. 27 as well, 27 doesn't work because it is a different number, so we want to write that as 3 to the power of something. So 27 is the same thing as writing 3 cubed. Maybe you can just check that on your calculator if you're not sure, especially if the numbers get any bigger. Now, again, what can I see here? What rule can I match up? You have the option of using this rule. Okay, but we haven't actually used this rule yet, so we're going to avoid it. And what we're going to do is we're going to use the rule we have been using. Okay, so when we're dividing, we're going to subtract the powers. So that'll be 3 to the power of 3x minus 1 is equal to 3 to the power of, now we're going to do 3 minus a half. We still have that 5 then. So 3 to the power of 3x minus 1 is equal to 3 to the power of 2.5 to the power of 5. Now, when we have the brackets and two powers, when we have a power raised to a power, you multiply them. So it'll be 3 to the power of 3x minus 1 is equal to 3 to the power of 2.5 multiplied by 5, which gives me 12.5. Okay, so how did I get that? 2.5 multiplied by 5. Now we are back to the situation we like. We have the same basis, so we are going to be left with 3x minus 1 is equal to 12.5. Solve for x plus 1 to both sides. And divide both sides by 3. So we'll get x is equal to 4.5. Okay, again, that is possible to check. Similar to what we have been doing, sub it in, see what decimal you get out. Do the same thing with the other side, put that into your calculator, you should get out the same decimal. Okay, so in terms of exam level, any of those kind of more the later questions, particularly that question 8 there, is as hard as it can get on an exam. Okay, there is another way to do that question as well, using this law down here. We haven't really touched off of it a lot of the time, you can avoid it. So the main ones that I focus on are these top 3 here. This one here comes up quite a bit, and this one here comes up quite a bit. They would be my main ones. Also this, any number to the power of 0 is 1. So if I have 10 to the power of 0, that's 1. A million to the power of 0 is equal to 1. It's a little bit counterintuitive. You would think anything to the power of 0 would be 0, but it is in fact 1. You can always check that on your calculator anyway. Okay, so that's us done with indices. What we're going to just flick forward to now is we're going to have a small look at surds. Again, it's not a big part of the Leaving Cert course, but if it did come up, it is handy marks, and also you will get no marks if you just do it on your calculator. Okay, so here we're going to write the square root of 50 plus the square root of 8 in the form k root 2. Okay, now surds just means square roots. You'll see that word surd a lot. So leave your answer in surd form. That just means there needs to be a square root in it. Okay, we're going to start with the square root of 50 and we're just going to work with that for a second. Okay, now what I'm going to do, I'm going to multiply or write down all the numbers that you can multiply together to give me 50. So we can do 50 and 1. We could do 2 and 25. 3, 4, 5. We could do 5 and 10. Okay, and I think that is it. Now, what we're going to do is, see this square root 2 here that we want in our answer? We're going to pick out the one that has that number. Okay, so we can say that root 50 is the same thing as root 25 times root 2. Take the next one again, root 8. So what numbers can I multiply to give me 8? I can do 8 and 1 or 4 and 2. I'm going to pick the pair 4 and 2 because it has this, what we're looking for up here in the question. Okay, so I can say that root 8 is the square root of 4 multiplied by the square root of 2. Now, if you're not sure, you might know this anyway. Square root of 25 is just 5. Square root of 2. And square root of 4 is 2 root 2. Okay, so now if I want to add square root of 50 plus square root of 8, I can actually add 5 root 2 plus 2 root 2. If I have 5 of them and I have 2 of them, in total I have 7 root 2's. Okay, so that is root 50 plus root 8 in the form k root 2. That is all there is to it. Okay, if you want to try question 10 ahead of me, maybe pause the video. That is a 99. There, just that 9 got a bit blurred. Okay, so root 44 plus root 99. If you think you can do it, exactly the same method as above, work ahead of me, or else I'm going to do it over here right now as well. Okay, again, your calculator will do this for you, but if this does come up in an exam, it would probably say without the use of a calculator or show your workings completely, which means you will not get your marks if you just fire it into your calculator. Okay, so we'll start with root 44. What numbers can I multiply together to give me 44? But I know there needs to be an 11 in it, so I'm going to pick 4 and 11. What numbers can I multiply to give, so root 44 is equal to root 4 times root 11. Root 4 is just 2 times root 11. And then root 99. Again, I need an 11 in it, so it's going to be 9 multiplied by 11. So it'll be square root of 9, square root of 11, which is 3 root 11. And we want to do root 44 plus root 99. So I can just say that that is 2 root 11 plus 3 root 11, which is 5 root 11. The question said find n. N is the number in front of the root 11, so n is equal to 5. Okay, that is, I know it's very quick, but that is really all there is to surds. There is not much more to it. And I think if it was to come up in an exam question, that would be something that, a way that it could come up, or kind of an expected way it might come up if it were to appear in your leaving cert. Okay, so what we're going to do now is going to do some scientific notation. Okay, if you want to pause here and maybe screenshot or just take this down as notes, this would kind of be what I'd be practicing, and then we'll do some questions in a second. Okay, so scientific notation, it's just a way of writing really, really big numbers or really, really small numbers. So we'll look at the small numbers first. Okay, so obviously 0, I'll just get rid of this for a second. So 0.0023 is a really, really small number. Okay, so what we're going to do is we're going to move the decimal point until we get a number between 1 and 10. Okay, now we will see in a second how this question will be asked, but for now we'll just go with kind of just write it in scientific notation. So instead of writing it as 0.0023, what we're going to do is we are going to start our decimal point, and we're going to move it until we get a number between 1 and 10. So I can move it 1 place, 2 place. If I stop here, I'm going to get 2.3, which is a number between 1 and 10. Okay, now this will always be the same, so it'll always be multiplied by 10. And then how did I get to the power of minus 3? Because I moved it 1, 2, 3 places. Okay, and the power is always negative if your number is small. Okay, take a look at the next one then. So obviously 0.0000009756 is a really, really small number. So to write that in scientific notation, we're going to move our decimal point 1, 2, 3, 4, 5, 6, 7 places. If we move it to there, we get the number 9.756, which is a number between 1 and 10. And then count how many places you move the decimal point. So you moved it 7 places. It's a really small number, so it is a negative sign. So a negative 7. Okay, it'll always be by 10. Okay, then if you have really big numbers, it's actually the same thing. Okay, for really big numbers, if they don't have a decimal point, you put the decimal point at the end, and we just move it the other way until we get a number between 1 and 10. So 1, 2, 3, 4, 5 places. That'll give us the number 3.54. And then by 10 to the power of 5, when it's a really big number, it will be a positive power. Okay, same thing here. So decimal point, pop it at the end, and then move 1, 2, 3, 4, 5, 6, 7, 8 to get the number 1.234 by 10 to the power of 8. Okay, now we're going to just have a look in a second now at how that can be asked, but that is the basics to it. Okay, now how this question comes up in an exam, it could be, for example, in an area and volume question. Okay, if you get out a number that was really big or really small, they may say express your answer in the form a by 10 to the power of n. Okay, if you see this anywhere, that just means scientific notation. It could come up in a financial maths question. Okay, so if you had someone who was a multimillionaire, they may say write this value of money in scientific notation. Okay, it has come up quite a bit, often linked in with other big topics. Okay, but it is an important skill. I kind of put it in the same bracket as rounding, when you're studying your rounding, throw this in with it as well. Okay, so we're going to write the following numbers in the form a by 10 to the power of n. We know that just means scientific notation. Okay, so first thing we're going to do, first number is a really, really big number. Okay, so we're going to pop our decimal point at the end, and we're going to move it 1, 2, 3, 4, 5. So that is the number 3.24 by 10 to the power of 5. Because it's a positive number, your power will be, or because it's a big number, your power will be positive. Next one then, similarly again, so if you want to pause the video and just make sure you're getting this answer right. Okay, so we're going to start your decimal point at the end. So we're going to start it here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1.0125 by 10 to the power of 8. Okay, there's no need to write all these zeros at the end. If you do write them in this case, it wouldn't actually be wrong, but there's just no need to write them in. Okay, question 3 then is a really small number. It already has a decimal point. So we're going to go 1, 2, 3, 4. To get the number 1.23 by 10 to the power of 4, and we need to put minus 4 because it was a really, really small number. Okay, and again, if you want to pause the video and just try the last one quickly. Have our decimal point here, 1, 2, 3, 4, 5, 6. So it'll be 5.6 by 10 to the power of 6, and it'll be minus 6 because it's a small number. Okay, and that is all we're going to look at for scientific notation. As I said, it often comes up kind of thrown into a different topic. Often a place where you end up getting a really big answer and just say change your answer into scientific notation. But again, it will probably say a by 10 to the power of n. Okay, I threw it in with indices just because people just tend to kind of lose it. It's not a big enough topic to make a video on its own. And I guess there are powers involved in it, so it is kind of linked in with the overall topic of indices and powers. Okay, so just recognize when to use it. It'll be something like that question that's written on the screen there, something multiplied by 10 to the power of n. All this means here, a has to be a number between 1 and 10, but we were kind of doing that anyway. Here I was like, okay, we'll move it to this point because that's a number between 1 and 10. You'd be wrong if you stopped here because 32.4 isn't a number between 1 and 10. Okay, but always for scientific notation, you're looking for a number between 1 and 10. Okay, so what we're going to do now is we are going to do our exam questions. Okay, now I've actually only included exam questions from indices. I haven't from scientific notation, basically because when it has come up, it's been kind of, there's been a big backstory to the question. You might have had to find the number or understand what the question was about. But if you can understand that scientific notation, then as long as you're able to do whatever question was asked, the last step will just be writing in scientific notation. But they are no more different to any of those questions there. So if you can do those questions, you'll be able to do whatever scientific notation question comes up. Okay, now for exam questions, I'd really encourage you here to pause the video and give this a go, see what you would do with it. This came up in 2020. It was question 4C and it was worth 10 marks. Okay, so quite a generous amount of marks. You'll probably see that this question is a little easier than some of the ones we had been doing. Okay, so pause the video here and give it a go. I have your rules of indices there on the right hand side. Okay, so my first observation here is that we have different bases. So one of them is a 2 and one of them is an 8. So I'm going to show as much work as I can. So I'm going to say that 8 is the same. I want to change it to 2 to the power of something. So on my calculator, 2 squared is 4. 2 to the power of 3 will give me 8. Okay, so we have 2 to the power of 9x minus 1 is equal to 2 cubed. And don't forget, we still have that 2x outside the bracket. Okay, a lot of the time, a common error would be that people would forget about this. Okay, now left hand side I can't do anything with that. Right hand side I can see that that is like law 3. So what we can do with that 3 and that 2x, we can multiply the powers to give me 2 to the power of 9x minus 1 is equal to 2 to the power of 6x. 3 multiplied by 2x will give me 6x. Now I'm at the place where I have the powers that are the same. The bases that are the same. So you can just let the powers equal to each other. So we get 9x minus 1 is equal to 6x. I want x on its own. So what I'm going to do, I'm going to get all my x's to one side. So I'm going to plus 1 to both sides just to get rid of that from that side for a second. And then minus 6x from both sides. A few different ways you could have done that there. So I'm getting out that 3x is equal to 1. Divide both sides by 3. We get x is equal to 1/3. Okay, now once you get to that stage in an exam, move on, you have an answer. But we're going to pretend now that you are finished your exam, you have half an hour left, and you're going to go back and try and check some of your work. Okay, so this is the perfect question to check because we'll be able to do it nice and quickly, and then we'll be able to move on. We'll know we're definitely correct. So I'm going to do a check. I'm going to do it over here. Remember, I'm not necessarily getting any extra marks for this because it didn't ask me to do it, but a little bit for peace of mind, knowing that I'm correct, it stops me wasting time looking for a mistake if I know that it is correct. Okay, so I'm going to do 2 to the power of 9, and instead of x, I'm going to put in 1/3. Minus 1 is equal to 8 to the power of 2 by 1/3. Okay, now for here, there's a few different ways you could do it. I'm actually going to use my calculator. So into your calculator, make sure you can do this because it does take a little bit of practice in your calculator. 2 to the power of 9, bracket 1/3, bracket minus 1. That gives me 4. And then same thing at the other side, put in 8 to the power of 2 multiplied by 1/3. That also gives me 4. 4 is equal to 4. That's right. I then know x is equal to 1/3 is the correct answer. Happy days. I know I have my 10 marks there, provided I've shown all my work. I can move on and check another part. Okay, so that was the 2020 question. I'm just going to flick back now. This was the 2012 question. Extremely similar. So what I want you to do again, pause the video, solve for x, so get an answer for x. And here they actually wanted you to verify your answer. So you are going to get marks for that check. Okay, so I want you to try that as well, and I'll go through it in just a second. Okay, so extremely similar. My first observation is that one of the bases or one of the big numbers is 49. The other one is 7. That doesn't work, so I'm going to see what I can change them to. You will get familiar with these numbers, but straight away I know 49 is 7 squared. So instead of writing 49, I can write 7 to the power of 2. Here then, I'm like, okay, we have the brackets. We have a power raised to a power. Should be familiar with this. We've used this for loads. That'll be 7 to the power of 2x. It's equal to 7 to the power of 2 plus x. Base is the same, so we can just let the powers equal to each other. So we'll get 2x is equal to 2 plus x. We want to solve for x, so get all our x's to one side, so minus x from both sides. We get that x is equal to 2. Okay, so that is the first part of my answer. People often get a bit confused when it says verify. Verify just means check. It is what we have been doing with some of the questions all along. So that should not pose any difficulties to us now. So our check or our verify, we're going to say 49 to the power of 2 is equal to 7 to the power of 2 plus x, which is 2. Okay, I'm actually going to use my calculator again here. So 49 squared is 2401. That's 7 to the power of 4. So 2401. Put 7 to the power of 4 into my calculator. We get out 2401. Okay, so we get both sides equal to 2401. And then if you want to be fancy, you can just write therefore with those 3 dots verified. that x is equal to 2. Okay, or I have verified that my answer is correct. No harm to put some bit of a conclusion to it. Okay, so indices have come up in other parts of questions as well. But I suppose what our main focus on this video was solving for x when it was trapped in a power. So that's why I picked out those 2 questions. Okay, so just a quick recap on what we've done. So we were applying our rules of indices. What you should notice is some of them are used more than others, some more often than others. Focus on the main ones and then just kind of see, okay, the other ones are there, should that come up? We did a lot of solving for x as an index. That's the most popular exam question that comes up in it. We had a quick look at surds, not a huge section of the course, but still important, could pop up somewhere. And then we looked at writing numbers in scientific notation. So that is important, has come up quite a lot. But just like the questions that I said there, to be a random number and you just have to write it in scientific notation. Could come up linked with any topic, paper 1 or paper 2. It has come up on both of them. So just be prepared for it. But if you can do those 4 or 5 examples that we did, that is you covered for that question. Okay, so thanks guys. I hope you found this useful. And that you have, if you can understand this, that is your study for indices done.